Hello everyone. Today, on the occasion of Thesis presentation, I am presenting my topic AirOPS-AI, unleashing the power of AI and data science to revolutionize the airlines operations. So the main focus of the project is first of all the passengers. From the passenger point of view, we have developed some part of coding, then the assistance side, and then optimizing the overall airlines operations. So let's go ahead with the introduction. First of all, the objective. The objective is to optimize the airline operations with the scheduling aircrafts and then predicting the flight statuses and delays, and then equipping the airlines with the business intelligence dashboards. And then approach is to utilize artificial intelligence and machine learning data science to address the various problems like flight planning, resource allocation, and enhancing the overall operational adaptability. The impact of this project will be like minimizing the disruption which happens a lot, like about the delay predictions and all, and then ensuring the passenger satisfaction, passenger safety, and the way of advancement in the aviation industry. Specific items which are addressed by the project is first of all airlines operations optimization, in which we have developed code files which works on the flight fare prediction from the passenger point of view, and then there comes passenger satisfaction, flight scheduling, fleet management, crew allocation, and also resource utilization based work. Then we have developed code based on flight delay and flight status prediction, wherein it takes in account the historical data and also the parameters such as weather patterns, air traffic congestion, and other relevant factors. And then we have developed model which can predict delays and status. Then real-time analytics. So like we have developed a Power BI based dashboard in which there are real-time analytics and insights based on the flight statuses and the reviews, recommendations about particular airlines. And the last part is about passenger satisfaction and happiness and passenger safety. It literally focuses on the passengers' safety point of view, where video surveillance and security part comes, wherein I have focused on the integration of deep learning strategies and computer vision and YOLO versions of the deep learning part, where we are focusing on the weapon detection, then people tracking and counting, also baggage scanning, which takes a lot of time by the manual systems, and then prohibited item detection, thereby addressing the baggage scanning, and then also the violence detection and behavior, abnormal behavior detection kind of things. Research question: to what extent amalgamation of data science, machine learning, deep learning optimize airline operations and enhance security in airports while addressing ethical and regulatory concerns? Existing systems and what is the need of updations? So there are systems which are computer based, and long back in 90s it was purely manual system. From 2000 updations happened, but now also there are computer based systems, but rarely there are some airports which have enabled the machine learning and AI based systems in it. So there is need of updation because machine learning and AI based systems are highly accurate and precise in nature, and since they are fully automated by a machine, so there are less chances of the human error. These are the I will say primary implementation based papers which I have reviewed, and it's like more than 20 to 25 papers which I have reviewed for this literature. This is a research protocol diagram, wherein the first thing which I have focused is defining the research objective, where I have understood the research objectives, goals, and then I have derived the research questions. The next part is literature review and data collection, in which we analyze the literature review and then follow the trends and patterns and gain the knowledge about it, and also try to gather relevant data sources from it. And then the next part is about research design and planning of the implementation, where I have tried to focus on the CRISP DM methodology, kind of research design, and then working on the development of the machine learning models. The next part is about data processing and analysis, where we have finalized the data sets, and then data cleaning, data processing, data pre-processing, and then the model training part. And finally, the evaluation part, where we can check the accuracy of the models and working and testing of the models. And the last thing is reporting and finalizing the findings and analysis of the overall project which we have developed. Design specification. So the whole project I have divided in four components. First one is airline operations optimization, then flight delay prediction, and then real-time analytics, and then video surveillance and security part. These are the component-wise specifications. So first one, airlines operations optimization, in which we are analyzing the current schedules, we are optimizing the flight schedules, and then flight fare prediction and passenger satisfaction part is there. The next part is about flight delay prediction, in which we have worked on data collection with regard to the air congestion and air traffic management, and or the existing data set about the flight statuses, and then historical data analysis, then pattern analysis, and then machine learning model training. The next part is real-time analytics, which is purely based on Power BI. So again, for that, we have scrapped the data and then cleaned the data and then updated in the BI kind of mechanism, where we have developed a dashboard which can visualize the recommendations and flight performances metrics. And then the last part is about passenger safety, so in which video surveillance and security part is there, wherein we have worked on baggage scanning, weapon detection, people tracking, violence and abnormal behavior detection. So let us go into each one of them. So the first one, airlines operation optimization from the passenger's point of view, in which the first part, passenger satisfaction. So we have performed extensive exploratory data analysis, where in the first graph you can see it's about the arrival and departure time delays, and the straight line shows the linear relation between those two. Then the second is about the loyal customers and the disloyal customers graph. The next part also says about the legroom services and flight distances, and then in-flight entertainment. It's like passenger satisfaction point of view. And for this, we have developed, like we have trained the model with 10 different algorithms, and then the best one was, I think, XGBoost from this, and we finalized working with that and we tested the results. The next was about flight fare prediction, in which there are airlines versus its price, as you can see in the first image. And the second image is about days left for the departure and its increasing price as per each and every flights. And this is the accuracy chart of the model which we have developed. So from this, the first accuracy, like the highest accuracy which we have achieved, is from XGBoost. So we finalized it working with it. And the second graph is about the area under the curve, like ROC, receiver operation characteristics. This is again the linear relationship between the predicted price and actual price. About the flight delay prediction, so it's the final output of what we have prepared for the flight delay prediction. The accuracy, training loss, and then testing loss, validation loss, accuracy, and its time. So model 1 has like 3 hidden layers of like 500, 250, and 10 neurons, and model 2 has 3 hidden layers, again in which it was like 150 and 50 more neurons. Model 3 has again 50 and 25 neurons, like that. And like what we have observed is model 2 was chosen for future investigation because somewhat the lower validation loss was found in that model. This is the BI dashboards, previously worked coding part, wherein we have scrapped the data from the Beautiful Soap site, in which it was about the airline reviews and recommendations. From that, we have scrapped the data and then cleaned the data, and then we have uploaded to the BI dashboard, and the dashboard looks like this, in which we have reviews, we have number of ratings, and then recommendations, then average rating per category, seat type, traveling type, and then we can also choose particular airlines from this bar, then trip verified, year, what year we want to choose, and as per that we can get the ratings and reviews from this BI dashboard. The next one is about video surveillance. So for video surveillance, the difficult part was to get a data set, a publicly available X-ray scanning data set. But after extensive literature review study, we got one study which was about particularly about one data set of baggage scanning. So from there, there is one file which was like encrypted file. So what we did is the encrypted file was containing this kind of images like baggage scanning images of the um, blade and then pistol, blunt, and various other materials. And the encrypted file, for that encryption file, we have decrypted the file using darknet, and then we have implemented the convolutionary neural network, and then we successfully built a model which can uh, recognize or detect particular items from it. And then about the weapon detection, again the same thing, but for weapon detection we use different data set which was publicly available like very easily. So from there we have developed again the same YOLO 3 and object detection and OpenCV strategies were used to develop this. Violence detection and people tracking, again YOLO 3, YOLO 4, OpenCV and object detection technologies and techniques were used in it, wherein it detects the abnormal behavior, violence detection, and then people tracking, in which it tracks the number of people and it keeps on changing the count if the video, like if you'll play the video. And these are the results of it. So this particular result is about the convolutionary layers of the violence detection system, and this is about the people tracking and counting accuracy results. The first image shows the predicted and the actual count of it, and this one is the epochs versus the training, like training and the validation graph, and this is the mean square error of it. Thank you so much for listening.